Alright, this is the last thing we're doing this chapter. We're going to be solving radical equations. So, just something to remember, that if you have something equal to something else, so for instance A equal B, you can raise both of them to the same power and it's still the same equation. To solve radical equations, you must isolate the root symbol and use set notation for your answer. Please use set notation. So real answers go in the bracket, extraneous solutions go out of the bracket. So let's isolate. Solve cube root of x equals 4. Move over the 4, so you have the cube root of x is equal to positive 4. To undo a cubed root, you raise both sides to the third power. So you get x is equal to 64. Real quick, just double check. I could plug a 64 in here. You could take the cube root of it. It works. There's no problem there. So my final answer is 64. Over here again, isolate. So I'm going to move over the fourth root of x. So I have 5 is equal to the fourth root of x. You could have also moved the 5 over and divided by a negative. It's the same thing. Raise both sides to the fourth power. And then you get x is equal to 625. Which again, you could put 625 in a fourth root. You could take the square root of a positive number, or a fourth root of a positive number. So my final answer is 625 in the brackets. Number 3. Alright, first things first with this one. You want to get x by itself, so you want to divide by 2. So you have x to the 3 halves equals 125. Now, to undo 3 halves, you want to raise each side to the reciprocal. So raise to the reciprocal. I'll write that over here. Power. Okay, so for this one, we're going to raise both sides to the 2/3. Okay, and when you type that into your calculator, you do get a nice answer. However, you could have practiced breaking it down like we were doing earlier. The third root of 125 is 5, and then square that, it's 25. So you should get 25 when you type that in your. You could just type that in your calculator. If you do not get a nice answer, you will have to break it down the way we've been doing earlier in the chapter. And 25 does work. Again, this is a square root because of the 2 on the bottom, but you can take the square root of 25 with no problems. Okay. Why don't you guys pause and try a couple? Number 4, divide by 3. And you get 81. Raise the reciprocal power. So we raise both sides of the 3/4. Okay. And again, you can either do this with the calculator or, work it by hand. X equals, well, 81 is the same thing as 3 to the 4th. I'm gonna do this by hand. Why not? So this is saying x is equal to 3 to the 12 over 4, which is the same thing as 3 to the 3rd, or 27. And again, that can work by plugging back in because you have a third root, which you could put anything into those. Alright, and finally the last one. We have to isolate the square root. So move the 2 over. We have the square root of 4x minus 7 equals 3. Square both sides to undo the square root, because square root is 1/2. And you get 4x minus 7 is equal to 9. 4x is equal to 16. X is equal to 4. Again, real quick, just double check. If I put a 4 in here, 4 times 4 is 16 minus 7 is 9. Square root of 9 is 3. So that will work. Alright, so those are those 5. Now, these are ones where you can get an extraneous solution. So when there's 2 root equations. First of all, what an extraneous solution is if I solve something like this. The square root of x equals -1. If I square both sides of this, I'm just doing this in the middle, I get x is equal to 1. However, If I plug 1 back into my original equation, is the square root of 1 negative 1? No, it's not. So we would say that 1 is an extraneous solution. So let's see what happens here. With two square roots, you want to break them apart, as in move one of the pieces to the other side. You don't want both of them on one side, if possible. And so for this one, we're going to do the square root of 3x plus 2 is equal to 2 root x. Square both sides. You get 3x plus 2 is equal to 4 times x. Move the 3x over, you get 2 is equal to 1x, and you get x is equal to 2 when you divide by 1. So we got 2. I plugged 2 back in just to double check. 2 times 3 is 6 plus 2 is 8. Minus 2 root 2, that's the same thing. 2 root 2 is the same thing as 8, that works. So you got 2 as an answer. Alright, let's do this next one. Now, when you square both sides, because it's already isolated, you do have to FOIL the left side here. So x minus 4 times x minus 4 is an x squared minus 8x plus 16 equals 2x. I move that over to set it equal to 0. And now I see if I can factor it again, which I can. 8 and 2. So I have x equals 8 and x equals 2. Now I have to check both of those from the original problem. If I put, here's where we have a problem. 8 should work, right? 8 minus 4 is 4, you get a positive. 8 times 2 is 16, you can take a square root of that. But here's the problem. Put a 2 back in. If you put a 2 back into the x minus 4, you get a negative 2. There is no way that this square root on this side can come out to be a negative. So my solution for this problem is that 8 is a solution that is real and it works, and 2 is an extraneous solution because if you plug it back in, it doesn't match up. So always check that always check these, always. Alright, last one. Same thing. Square both sides. You get x squared plus 4x plus 4 equals 2x plus 28. Move everything to one side, and you get minus 24. So x squared plus 2x minus 24 is equal to 0. You can factor that with a 6 and a 4. I believe x plus 6 and x minus 4. So x equals negative 6 and x equals positive 4. Well, again, which one of these will work? Let's try the negative 6 first. If I put a negative 6 over here, I'll just show the work. Negative 6 plus 2 equals square root of 2 times negative 6 plus 28. Well, right away, this is negative 4 over here. Negative 4 does not equal the square root of positive 16. So negative 6 doesn't work. 4 will work though. 4 is all positives, nothing will be negative on the one side. So my final solution is that the 4 is the correct solution and the negative 6 will not be a solution. So there is my solution in set notation. So don't forget that. Alright, and that's all we're doing. It's just solving, trying to undo the square roots, the third roots, the fourth roots, the fractional powers. We have one more video after this, really quick, just 4 problems. If you want, you should just go on to that right now and finish it up. But if not, I will see you guys tomorrow.